So dear participants, let's get back with the discussion on counters. And in this particular lecture, this will be a very small lecture in which we will get into the various terminologies that are associated typically with the Allen Bradley counters. And also we will find some application of the counters, and I will talk about the assignment. Now you can see the first terminology that you come across in an Allen Bradley counter is the preset value. Now you see, preset value is actually the value that you program for the number of count that you want to be counted by that counter. So here you can see that it is the count value that the counter must accumulate. Now whenever I am talking, the value that the counter have to count is not a technical language. We must say that it must accumulate. It starts counting from 0 and it should accumulate that much number of count. That is actually the work of the accumulator. So preset value is the value that actually you use to program it. Okay, you use to program the counter. So whatever that value that you program the counter with is called the preset value. Now you can see next is the accumulated value. Next is the accumulated value, ACC. It is the accumulated number of 0 to 1 transitions of the counter rung. That how many transitions from 0 to 1 are taking place. Here you need to remember, although we are giving a complete pulse at the input, the counter actually counts the number of transitions from 0 to 1. And how many transitions have actually taken place, that is ultimately giving the number of counts, is given at the accumulator. It is the role of the accumulator to count that value. So this is denoted as ACC. Next there is count up enable bit. Okay, you can see this is CD and this is CU. So these are the two most important bits where you actually get each and every pulse at the output whichever is there in the input. Okay, so now you can see the count up enable bit is 1 when the input logic makes the up counter rung 1, and it is 0 when the rung is 0. So very simply, when the counter is counting and it is an up counter, under that circumstances it is 1 when the input condition is 1 and it is 0 when the input condition is 0. Next point is down count enable bit, that we are talking about this particular bit, down count enable bit, CD. Now you can see there the down count enable bit is 1 when the input logic makes the down counter rung 1 and 0 when the rung is 0. So very simply, whenever you get a pulse at the input and if the counter is counting, that pulse is available at the output, and that output terminal is either the CU terminal or CD terminal depending on whether it is the up counter or the down counter. Now let us see what are the other terminologies. Next, DN bit. You can remember this was the DN bit. Okay, so the DN bit is 1 for both type of counters when the accumulated value is equal to or greater than the preset value. So whenever your programming counting job is over, that means whatever preset value you had given, the accumulator has accumulated that value. Okay, then your done bit will be 1. Next, there is count up overflow bit. This is available with high category PLC, the higher class of PLCs. This is not available with generic normal, I should say low cadre PLCs. Okay, this count up overflow bit is 1 when the up counter increments above the maximum positive value, and definitely count down underflow bit should be 1 when the counter decrements below the maximum negative value. So overflow bit will be there for the up counter, and this count down underflow will be there for the down counter. Next, definitely there is a reset button. The reset returns counter accumulator values to 0. Remember, regarding reset you need to remember very clearly that when the reset is on, when the reset button is 1, accumulator and all output bits are held at 0. When the reset is 0, the counter is able to start counting again. So whenever the reset is 1, you cannot work with the counter. Whenever the reset is 0, the counter is ready for the counting. Now let us see applications of this counting. I will directly go because I am to cover this chapter very quickly so that we can conduct test of yours, second internal test. Now you see, this particular problem I have already discussed. There is a conveyor belt and there are items passing along the conveyor belt. The passage of an item past a particular point is registered by the interruption of a light beam to a photoelectric cell. And after a set number, there is to be a signal sent informing that the set count has been reached and the conveyor should be stopped. A reset signal causes the counter to reset and start counting again. The set signal is used to make the counter active. So under these circumstances, you can see here, this is the generic counter application. When the counter reaches the preset value, the done bit is set to 1. And so this output 01301, which is associated with the NO contact of this DN bit. So this DN bit, it is having one NO counter as well as one NC counter. You can use that NO and NC counter as much time you want to use in your program. So that you have used here and the output is associated with it. Now you see here there is another input which is given to the reset terminal so that you can reset the counter and make it ready for another series of counting. And there is the conveyor, which is connected to the NC contact of the which you have connected to the NC contact of the terminal. Now it is very interesting to see that how this conveyor is connected. You can find that this conveyor is connected to the reverse contact that is associated with this output coil. Now this output coil 013/01, it is connected to the done bit. That means we have already discussed that once the counting is done, the done bit is high. Okay, the done bit is high, that means it will activate this coil. Once this coil is activated, all the NO contacts that are associated with this coil, that will become NC, and all the NC contacts that are associated with this coil, that will become NO. So earlier the conveyor was one on, but now this NC will become NO and this conveyor will be stopped. So this is how you can see that a counter can be applied for controlling a conveyor. Now you can see that this is an up and down counter, that is with the typical Siemens notation. You can see here this is the up count input, this is the down count input, this is the reset input. Now you can see each input pulse to the CU input, this is the up count input, increments the count by 1, and each input pulse to the CD decrements the count by 1. There is only one output, so definitely you can find that CU and CD, both of them, they are working concurrently and that is generating only one output. The count is set to the preset value PV, and when the set or load input is 1, that means you can program this counter only when this set input is 1. As long as it is 1, inputs to CU and CD have no effect. So when this PV, that is when this count is set, that is the count is set to the preset value PB when the set or the load input, this is the S input, okay, it is 1. So in order to load your counter with the value of your wish, that means your programming value, you should keep this S, high. Finally, there is the reset input. Whenever it is high, all the counts are taken to 0. Now finally, this is the particular example that I had already given you in during the initial phase of our counting discussions. that we need to consider the task of counting cars as they enter a multi-storage parking lot and as they leave it. An output is to be triggered if the number of items or cars entering is some number greater than the number leaving, that is the number in the parking lot has reached a saturation value. The output might be to illuminate either a green lamp, a red lamp, or a no empty spaces sign. So under that circumstances, you can use either the Siemens up down counter or you can use this up counter and down counter separately, because it may so happen that your PLC is not having the up down counter facility associated with it. So under that circumstances, you can use this up counter block and down counter block in order to get such situations under your control. You can see here the input to this up counter is given through one of the contacts and the input to the down counter is given to another contact. Now you can see that the down counter, this input and this input, they are completely independent. Okay, this input and this input, they are completely independent, and you can find that C50, it is the done bit is ultimately given to the your conveyor controlling coil, or the rather I should say reset controlling coil. Now I have deliberately committed one mistake. In order to grab your attention. You can see here that I have told you they are different counters. However, their address is one and same. Although one of them is the up counter and other is the down counter. Only under that circumstances you can use the done bit. For collaborative counting of these two counters. Okay, because you need not to go for independent counting, you need to go for a collaborative counting, because effect of these two should be reflected to this done bit. Therefore, that is C5.0, it is used as a down counter, C5.0 it is used as an up counter. This is really possible. When you are doing the practicals, you can see that these things are really possible. Again, remember, I have deliberately done that mistake so that you can remember whenever you have to program under such situation that sir had committed the mistake, we should not commit it again. Now you can see here, suppose in these three cases, 1, 2 and 3, there are 3 cars that are entering the parking lot. Now here you can see after that there are 2 cars that are going out of the parking lot, and again 1, 2 and 3 cars are there. Now you can see we have programmed it for 4 cars. So in this circumstance, what is happening? 1, 2 and 3. 3 cars have entered, 2 cars have gone out. So now we have got only 1 car inside. After that, car number 2, car number 3 and car number 4. When the car number 4 is there, you can see that the done bit has become high. Whenever the done bit has become high, the output will definitely become high, because whatever contact we are using, that contact is associated with the done bit of these counters. Now this done bit is given to the output coil. 01310. And finally, when this everything is over, this contact, the NO contact that is associated with this output coil is given to the reset button. So whenever this particular contact is activated, that means it becomes NC from NO, this reset input is activated and your accumulator will come to 0. Now you can see here, once the done bit is over, this reset is activated and your accumulator has come back to 0. So this is all about counting application, and I finally officially declare that timer and counter unit is over, and with this particular lecture the discussions on every aspect of unit 2 is over. So if there is any problem that you feel, please let me know so that we are in a condition to appear for our second internal test. I wish that you enjoy this session, and I also wish that you could find some good text on this particular subject and go through it, because more you go through, more you learn. Also, I will send you one of the good topics that I could have found in net that I will definitely share with you. Thank you. Next, before I complete my all of the discussions on these counters, you can see that I have given some conditions as assignment to you. These are the some conditions which are actual applications that you may find with counters. Okay, so here there are 1, 2, 3, 4 and 5 conditions that you please think on these issues. You please think on these issues and see that how counters can be implemented in order to affect these situations. How you can implement. I ask each and everybody of you to talk with each other, discuss with each other, to see that how such conditions can be designed, or how such conditions can be generated for such counting application. Definitely I have the answers with me that I will share with you, but unless you are trying something, I am not going to give the things in free to you. So this is all about counters. Thank you and happy learning.